2.7 solving linear systems using matrices. Okay, so we've done elimination, we've done substitution, we've done wrapping, inequalities. We are going to now do matrices.
Are you already videoing?
Yes, I am recording. I did attach the old video online because Jalen needs it, but I am trying to record, trying to get back in that habit. So 1.7 solving linear systems using matrices. This is a nice organized method of doing this, but there is a method and you need to do the method that I teach you. It is not let me do whatever I want to do. There's a procedure and you must follow the procedure. We're going to start today and tomorrow with 2x2 matrices, and next week we're going to do 3x3. And I'm hoping we feel comfortable enough to just have a quick quest next Thursday and get it over with and start 2.1 on the following Monday. That's what I'm hoping. Right now I have it a little bit differently, but I'm hoping that's where we're at. But it does take, we will do them together. It takes time. The more proficient you get at it, the quicker they go. But if you never do them on your own, you're never going to be able to do them. Does that make sense? Okay, is everyone ready? Titled?
Yeah.
Okay, so first of all, what a matrix is. A matrix is a rectangular array of values. So -7, 3, 8, -4, 1, 0, 1, 0, 0, 1, or 0, 0. Those are matrices.
I thought it said mattresses at first.
No.
Wait, so -7, 3, and -4.
Those are called elements in a matrix. I'm trying to see if I can get the picture bigger for you guys. Nope, it's just changing colors, isn't it?
It's a party.
Oh, that helped. That's good. Or do that. Okay, so a coefficient matrix is a matrix that is full of coefficients with no variables. So if you look before you start writing, I'll give you time to write. I have a matrix down here that's AX plus BY equals C, DX plus EY equals F. You notice that the X and the Y are lined up. Yes?
Mm-hmm.
And then we have the coefficients, which is just 2, 3, 4, -2. Do you see that?
Yeah.
Coefficients have coefficients. That's all that's in there.
It's a circle.
No, that is a coefficient matrix.
Okay.
Okay, so an augmented matrix. So lots of definitions here, and I will use the words continuously.
Only the one on the far right is a coefficient.
Well, the A, B, D, E is coefficients when you don't know what they are. But like 2, 3, 4, -2 is an example of a coefficient matrix from this original system right here.
Okay. I'm writing down each of those, okay?
Oh, I wouldn't write down each of them. I would
Oh.
like,
I only have AX plus BY equals C, DX plus EY equals F, and then I'm writing right now 2X plus 3Y equals 1. 4X
okay,
plus-
these two, that when I have the box and the circle, are the most important ones.
Oh.
The A, B, C, D, E, F are just general numbers.
Okay. Then let me erase.
Okay, so an augmented matrix. An augmented matrix puts a coefficient matrix, that 2, 3, 4, -2. It puts the coefficient matrix next to the solution matrix or the constant. See that? Has the coefficients, and this little dotted line right here is what we call the augmented line. It just puts the two together.
Like
That the dotted line. Let me see if I can zoom in. Can you see that better?
Yeah.
Whoa.
Okay, so that dotted line is what connects the coefficients to the solutions. Okay, so I take my system that's right above here, right above. I have 2, 3, 4, negative 2. And the equal, think of this as this augmented line as equals 1 and 10. Everyone get where these come from?
Yeah. Can
'Kay.
you zoom out a little bit so I can see the definition?
Oh, it's just coefficients and the constants. That's all it
The
is.
dotted lines connects.
The dotted line is like the equals. So that. So something you need to know about the dimensions of matrices. Matrices are stated, we say they're a 2 by 2, a 3 by 4, a 6 by 8. We say the dimensions, it's like room dimensions. But these dimensions in particular are rows by columns. Rows go horizontally, columns go vertically. Okay, so if you think about it, you like columns in a room.
Yeah.
Okay, if I'm building a column, don't I have to start horizontally first and build up?
Yeah.
Yeah, I can't start in the middle, can I?
No.
So that's why we have to state rows first and then columns. So this ABDE matrix right here is a 2 by 2 matrix. Okay, but this augmented matrix down here is a 2, there's 2 rows by 3 columns. Jaden, you're spacing. Does that make sense? 2 rows, 1, 2, and 1, 2, 3 columns. Okay? Rows by columns. We will always put these X, Y, and the main point of doing these is not for 2 by 2 matrices. 2 by 2 matrices, you're going to use elimination, you're going to use substitution, but it's the easiest way to learn this method is on smaller matrices. Does that make sense? This is not practical for just a system of 2 equations like I have here, but it can be done. It's just much easier to do with elimination or substitution. The main point of what we're going to be doing is when we have a system of like 3 equations, 5 equations, 8 equations, that's when you would use this method. Okay? Everyone good? Okay, so I want us to write the augmented matrix for what I have here. So the first one I have is 2y equals 1 minus 2x, and 4x equals 10 plus 2y. So 3y equals 1 minus 2x, and 4x equals 10 plus 2y. What is wrong with this right now? They're not in order, right? They need to be alphabetical, X, Y, Z, A, B, C, whatever the variables are, and the equals always needs to be on the right-hand side. So it looks like I'm going to add 2 over.
Yeah.
So I have 2x plus 3y equals 1. Can you all see that?
It's very faint.
Yeah.
Can you make it thicker?
Yeah, I can make it a little thicker, but I'm also going to make it a little darker. I don't want to make it too much thicker because then it... Okay, so 2x plus 3y equals 1, and then I've got to subtract this over. So 4x minus 2y equals 10. Did that help a little?
Yeah. Yeah.
Okay. I think the color more than anything. So now I'm ready to make my augmented matrix. So I just make my matrix brackets. No, this thing doesn't like it that I hold my pen down long. It wants to make the shape. Okay, so I put my X column, so 2, 4. My Y column, 3, -2. My augmented line,
Can I try equals?
nope.
I have to put
You have to put this. They're matrix, you have to do it. Now you will see when I do my PowerPoint sometimes that it looks like little dots like this instead of just a dashed line. If you do that, you must put at least 3. You can't put 2 because that's a colon. Okay? You can't put 1 because that means multiplication. It's easier just to do a dashed line. Okay? So then over here, I have the system. I have a system of 3. So I have x plus 2y equals 2, x minus y plus 3z equals 5, and 2x plus y minus 4z equals 10.
Wait, that's all we do for the.
That's it. For right now, that's all we're doing. We're just setting it up. This
Do we have
is
to write the right side or no? Is that a completely different thing? Or is that literally how we got our answer?
that's how we got our answers.
Isn't the second one already set up?
So, well, are they both in X, Y, Z order?
Yeah.
I mean, all 3. Yes, they're already in order, aren't they? Okay.
So we just gotta make the column
So my X column would be what?
of X, X.
No, not X. Not X.
One,
Coefficients.
two.
1, 1, 2. Only coefficients. Okay. And my Y column would be
2,
Negative 1, 1.
my Z column.
0,
0.
3, -4.
You guys picked up on it. I didn't even have to tell you. Why'd you put a 0? Because there's not one there. If there's not one there, it's 0. Got it? And then
2, 5,
2, 5.
2, 5, 10. Do you see how I'm not squishing these together? Because if I squish them together, I'm going to think it's 20, not 2 and 0. Correct? You got to be neat. I know that's hard for some of you. So now, this last one, I have 0, 2, 3, 4, 8, -1, -2, 5, 2, 0, 1, 9. That's a matrix, yes? So now I'm going to go to a system. So this is my X column, this is my Y, and this is my Z, and this is equals. So see what you can do.
Don't this is really hard. I was joking. She didn't even teach me anything. Oh, so what are you? I was just talking to her. Makes sense to me how we got.
Okay, so did you get 2y plus 3z equals 4, 8x minus y minus 2z equals 5, and 2x plus z equals 9?
Yeah.
Okay, I would suggest that your z's get crosses on them. Why?
So
that way you know it's not a 2.
You know it's not a 2.
Do I have to put y? I put -1. Do I have to use y? You put ax minus y.
Yes, because that's what the coefficient is. There is a y.
Ax minus 1.
No, it's 1 minus 1y. Okay. So, these are our rules. And this is, if you don't finish a rule, you can go back and look at the video, okay? I want you to absorb what's going on right now. Got it? Got it? If you need time to write these down, you know where you can go look at this. Got it? Got it? Okay, so the things I can do with matrices. I can switch two rows or many rows. I can switch the rows, but I have to switch the whole row. Got it?
Got it.
Okay, I can switch a row. That's good. And we do that by we do like a little shorthand. We say like row 1, and I just do this. Little arrow, row 2. That's what I do. And then I do it. I'll show you how to do that in a minute, okay? The other thing I can do is multiply a row by a non-zero constant. Okay, big word there was what? Nope. Non-zero.
Yeah.
Okay, non-zero. And I also can multiply. Did I say divide?
No, you said
No.
multiply.
So if I want to divide something, that means I have to multiply by a fraction, yes? Division is not a thing.
Hey, you wanna go down there because last time she forgot.
Okay.
And then I almost didn't have time to brush my teeth.
Okay. So multiplication is the only thing you can do. So if you want to divide by 3, that means you multiply by what?
1/3.
1/3. So we do this. So how I would note this, I have 2, 3, 7, 5, 2, 9. And then I would next to this over here, I would write 2R2. And my result would be 10, 4, 18. We will not go sideways. I don't like that these are written sideways. We will go down only.
So the top one would be, wait, so why didn't you,
So the top one, if I did this one, 2, 3, 7, 5, 2, 9. Okay, if I switched them next to one of the two, I'd say R1 switched R2. And I would have 5, 2, 9, 2, 3, 7. We will go down only. Okay. The next thing we can do is we can add or subtract one row from another. And it changes the second one. So in this case, we have 2, 3, 7, 5, 2, 9. And what they say we're going to do is we're going to add row 1 to row 2. So next to row 2, you say R1 plus R2. R1 does not change. R1 does not change. The only one that changes is the second one. Okay? And all we write is the result. So 2 plus 5 is 7. 3 plus 2 is 5. 7 plus 9 is 16. Okay, so we only change the second one.
And you change the second one?
Only change the second one.
Change row 2?
Yep. Okay, now we end in what is called reduced row echelon form. The shorthand for that is RREF. We are not done with this process until it is in reduced row echelon form. If you look at this picture right here, what do you notice?
They're all in different rows.
What are the only things in the coefficient side of that matrix? Ones and zeros. And in the X row, there is only a 1 in the X spot. And in the Y row, there's only a 1 in what spot? The Y spot. And in the Z column, there's only a 1 in the what spot? The Z spot. So when I put that back into an equation, it is x equals -4, y equals 2, and z equals 7. And we will write our answer like this. It's called an ordered triple. If it's an ordered pair, we wrote it xy, yes? And this isn't xy, this is xy what? Z. They're always in alphabetical order. Yes?
So on the multiply, why do you only multiply the second one, not the top one? The
Be-
first one.
because that's the only thing they did. They just said 2 times row 2.
Okay.
So would you do, what happens at 2 times row 1? Would you multiply row 1?
Yep. Yep.
Okay.
If you chose to do that. Okay, so these are the things we are going to do to change a matrix from here, from the starting point, down to reduced row echelon form. So we can multiply one row, we can add or subtract rows. That's all we can do. Or switch them.
Miss Mika, I'm not letting you do that.
That's fine. If you want to write these down, I would spend your time to like go get the video and just freeze it on there and write it.
That's what I was gonna do.
Yes.
Okay,
Yes, it is on the old video and I'm recording right now.
because I didn't.
Yes. Okay, so we are going to use matrices and row operations to solve this. Now again, after we learn this method, if I gave you a 2-system equation, you would use elimination or substitution. This is not the appropriate spot to use this, but it is the appropriate spot to learn the process. Does that make sense? Okay, so the first thing we are going to do is make sure, is it in order?
Yes.
What do I mean by order?
Like variables.
X, Y, and equals, yes?
Yeah.
Is everything good?
Yes.
Okay, so since everything is good, again, guys, you are only going which direction? Down. If you do not have at least half a sheet of paper, do not start this problem. You got half a sheet of paper?
Yeah.
Okay. You will fold your paper in half when you work on these things, and I will show you that as we go. Because you don't go sideways, you only go down. Some people fold their paper in thirds because they want to do 3 columns. Okay? And also it helps you from looking at everything else that's on your paper. And after today, I will only use my document camera so you can see exactly how I would write it on paper. Does that make sense? Okay, so the first thing I'm going to do is make my augmented matrix. And I'm going to come over here so I don't run out of room.
So on our thing, are we supposed to use go down?
Yes, you are to go down. So
Go
3,
to the side.
what?
If I did go to the side and the other problems.
Do not do that ever again. Okay, -2, 5, 25, 4. Okay, so we have an augmented matrix. Yes? Okay, so our goal, remember, is 1, 0, 0, 1, and then we're going to have an X and a Y. That is our goal. Yes? So that is our goal to what we're getting to. So we're going to be eliminating. Isn't that how we got zeros before? Okay, so when I want to eliminate something in the first column, I'm going to use the first row. If I want to eliminate something in the second column, I'm going to use the second row. Get the pattern? If I wanted to eliminate something in the 8th column, I would use the 8th row. In order to be able to solve these, if you have 2 variables, you have to have 2 equations. If you have 3 variables, you have to have how many equations? 3. If you have 2 variables and 3 equations, it's either going to be no solution or infinitely many solutions. It doesn't work any other way. Okay? So, the first thing we always try to do, if possible, is get this leading coefficient right here to be 1. Can I get 3 to be 1 using 2? No, I cannot. So I'm going to have to do some subtraction, yes? So the way I like to do it, I like to go step 1 is going down. That's zeroing out this is my step 1. Okay? Then my step 2, I move over and I work on this one, trying to get it to be a 1. If I can. If I can't, without getting a fraction, I move on. And then I go up, and then I go back. So I go in this big circle, and I'll keep modeling it for you. And it's kind of hard to see when we're only doing 2 by 2 matrices. You'll really get to see it when we do 3, but it's a thing. So the first thing I do is I want to get this 2 to be a 0. Now, that 2 is in the first column, yes?
Yeah.
So I'm going to use the first row. I don't have any other options, but if I had more rows, I'd have more rows. So when I have the 2, what is the... This thing is going to drive me nuts. If I press too long, it tries to make like a solid shape. Okay, so I need that 2 to be 0. So I have a 3 and a 2. So what's their least common multiple? Least common multiple. Like if we're doing elimination, you just had a test, yes? You want to eliminate the 2. You have 6, yes?
Yeah.
Okay, one of those needs to be negative, yes?
Yes.
So I'm going to multiply, I'm going to say negative 2R1 plus 3R2. Now take a second and absorb my shorthand. Can you see that?
Yeah.
It says negative 2R1 plus 3R2. That is what I'm going to do. The only thing it's going to change is row 2. So I'm going to write row 1 right now so I don't try to change it. Bless you. Okay, I'm not changing row 1. I'm using row 1 to change row 2. You notice, where did I write it next to? Row 2?
Yeah.
You see that? So my result is going to go there. So I'm going to do a lot of stuff in my head. Some of you are going to love this. Some of you are going to hate this. If it can't go in your head, this is your workspace, not your matrix. Got me? Everyone understand? This right here tells me what I did to get this result. And over here in that circle is any extra math that your brain can't hold. Got it? If you ever look at my paper, you're going to see lots of dots because that's how I keep my brain, how I keep it in my brain. Okay, so this is, watch how I do this step. I'm going to talk out what my brain is going through. So look up here. Don't be writing. Watch. Okay? I go negative 2, 3, negative 6, 3, 2, 6, negative 6, 6, 0. Negative 2, 4, 15, 19. Negative 2. Sometimes I'll do negative 50 when these numbers get bigger. That's my brain right there. Negative 50, 12, 8, 4, 38. Negative 38. That is what my brain goes through. This is what I did to get this new row. Does that make sense?
No.
Okay, I needed to eliminate this 2. Yes? So this one right here. Okay, I needed to eliminate that 2. So since I needed to eliminate that 2 and it's in column 1, I focused on row 1. So I have 3 and 2. So the least common multiple of 3 and 2 is 6. So I multiplied the first row by negative 2 and the second by 3. I like to keep my negative in the row that's not changing. I do better with it. Okay? Instead of thinking of it as subtraction. So then I do it. So negative 6 and 6 is 0. 4 and 15 is 19. Negative 50 and 12 is negative 38.
So you gotta look at the one. You
Okay.
try that, and then you do your I subtract. And then that's how you get the second one. Row two, that's how you got that.
So keep watching, I'll keep talking, okay? So I got my 0 here, yes? I got my first step. And I said my second step, I like to go this way, and I like to get this to be 1. Well, I bet 19 times 2 is 38, isn't it? So I'm going to take 1/19 of R2. Now, if row 1 was all divisible by 3, guess what? I'd take 1/3 of it. But is it all divisible by 3? No, I'm not going to give myself a fraction. Not going to do it. Okay? So I'm not changing row 1, so I'm just going to rewrite it. You will notice when I do them, I rewrite what I'm not changing, because if I don't, I try to change it. Okay, so 1/19 of 0 is 0. 1/19 of 19 is 1. And 38 divided by 19 is -2. Okay, so now I got my 0, I got my 1. Now I need to get my next 0. So that 0 is in the second column, so I'm going to use the second row. So I'm looking at this 1. How am I going to use this 1 to make this a 0? I'm going to multiply it by what?
1. Or 2.
2. Because I need it to be 2. Yes?
I think it should need to be 0.
No, I need the -2 to go to 0. So I need to multiply this 1 by 2. So I'm going to say 2 R2 plus R1. I'm writing it next to R1 because R1 is the only one changing. So I'm going to write row 1 or row 2 because I'm not changing row 2. Everyone following? So 2R2 plus R1. Well, 2 times 0 is 0 plus 3 is 3. 2 times 1 is 2, and -2 is 0. 2 times 1 is 2. Minus 2 is 0. 2 times -2 is -4. So if you want to write -4 out here, can you? Yeah. 25 minus 4 is 21. So now I've got my 0, my 1, and my 0. All I need to do is get my what? My last 1. Now, if I get a fraction, do I care? No, because I'm done using everything. So I need 3 to be 1. So I have to multiply it by what?
3. Or no, it.
No negatives. I need it to be 1. What do I multiply a number by to get it to be 1? It's what? I want 3 times x equals 1. What would I multiply by? 1/3. I multiply it by its reciprocal, yes? If it was negative, I'd put negative the reciprocal so it became positive, right? So I put 1/3 R1. So 1, 0, 7, 0, 1, -2. And my final answer is 7, -2.
Where'd you get 7 from? Yeah.
1/3 of 21. You got to do it the whole way across.
Wait, so you're dividing that thing?
And you're multiplying it by a fraction. I'm not going to say the word divide.
So,
Isn't division multiplication by fractions?
yes.
Yes. But you're not dividing because it's not allowed. Because in my rules, did I say I could divide?
No.
No. I said I could multiply by non-zero. So Maya kept yelling 0. Nope, no zeros. That'd be easy.
Where'd you get, on the very first one,
Mhm.
where'd you get 50 and 12?
Because right here I have -2, the very first step. It says -2 R1. So -2 times 25 is -50. And 3 times 4 is 12. So you're doing this to this one to get that answer.
Okay.
It's what I did to get my answer, not what I'm going to do. Okay? What do I always ask you? How did you do that? This is my how. I can pick up my answer key that I made 4 years ago, and I can tell you exactly every single step what I did to get the next step because of what? That. Okay? Yes, Emma?
No, I don't need to wait.
Can I-
I just need to look at it.
Can I write this down? Or are you still going?
I think if you haven't started at all, I think let's do another one and you can go back and write them down. Does that make sense? Because you might want to listen to it again. Okay. Everyone that had started, are we good?
Yeah. Sure.
Well, had you even started writing it down?
Yeah, I have like 4 of it written.
Okay, so there's only 5, so finish. That's why I said anybody who had already started writing it down.
I just have 3 negative 225.
Say that again.
I just have 3 negative 225. on the
Right.
first one.
So I would go and rewatch that as you write it. Because if you just write it, you're just scrambling.
I kind of understand. There's like a lot.
But it is, and it takes time. And if you don't practice it, you will not be able to do it. Yes, sir.
I'm a little confused on the step where you got 3, 0, 21.
Okay, right here.
Yeah.
Okay, so I needed to get this -2 up back here to be 0. Because my up here, I have it right here at 0. So it's in the second column, so I need to use the second row to do it. So I looked and I said, what would I do to this 1 right here to get it to 0 out -2? Well, I have to have it to be a 2, don't I? So I multiplied that whole row by 2. So right here I have 2R2 plus R1. So then this is what I'm doing.
I understand now.
You got it? Okay.
Because 2 times negative would be
Yep.
3 or
2.
4, 25 minus
No, it's 2 times row 2.
Yeah.
So it'd be 2 times 1 would be 2
2 times
minus 2 would be 0. Because I'm not multiplying row by 1 by anything.
I know.
Oh, okay. I thought you said you were.
I'm doing the little dotted line.
Oh,
2 times
the
negative 2, 25
constant.
minus 4,
Okay.
21.
Yep. Okay, we're good to do another one? Okay. You can watch it. Like I said, I'm going to post the video so you can just watch if you want to just watch. Okay. So I have 3x minus 4y equals -18. And -4x plus 8y equals 32. Are they in order?
Yeah.
Yes.
Yeah.
Yes. So I'm going to make my augmented matrix. So 3, -4. Some people do rows, some people do columns. I just do the columns. I think it's easier.
What's rows?
Rows are sideways. Rows are horizontal. And then -4, 8, -18, 32. If you want to use scratch paper rather than line paper, because sometimes lines get in the way of our brains thinking, I have tons of scratch paper. I will tell you, this is the section where people go, I want to use scratch paper, and they never go back to lines
Can you
because it frees them up.
Can you do y? Because since one's already negative, one's already positive.
We don't want to do, okay, this is my thing. We want to do X's, then we want to do Y's,
Oh.
because what will happen is if we do the Y's first, when we go to the X's, we could add things back in. And we don't want to add things back in.
Well, the 4's already. The
Right.
X is already at negative.
Right, I get that. So our goal is to have 1, 0, 0, 1. Yes? So that's we want to keep our picture in our brain. So we're going to go
So if you-
down, over, up, back if we have to. Now, if the whole row 1 was divisible by 3, I would multiply by 1/3 right now. Why am I not going to do that? They're not all divisible. Do you guys want to work with 4/3 as we work through this? No. Okay, so I need to get this 4 to be 0.
So just times it by 4.
4R1.
4
plus
times negative
3R2. Right?
One of you was right. I don't know which one said it.
4R1 plus 3R2.
4R1 plus 3R2. And I'm going to stop before we do anything.
Why?
You notice I wrote it next to row 2. Yes? Everyone notice that?
Yep.
Because we're changing row 2 only. And the reason why I did 4R1, 3R2, because what is the least common multiple of 4 and 3? 12. Okay?
So where's 12 at? Or like,
Actually, I'm going to do something different. I don't want to do that.
why did you?
Look at row 2. What do you notice about it?
It's negative 4 and 8.
4 goes into all of it?
4 goes into all of it, yes? And since 4 goes into all of it, could I get 1 really easily?
Yeah.
So, you know what I'm going to do? I'm going to put row 1 switched row 2. So negative 4, 8, 32, 3, negative 4, negative 18. And I'm also going to warn you guys, if I write down garbage, am I going to get garbage? Yes, what I mean is if I forget a negative, am I ever going to get the right answer? No.
Okay, wait. So if you just want to switch the rows, you just have to write R1.
Switched with R2.
Okay.
Yep. Okay, now I'm going to, I should do negative 1/4 R1 because I need a positive 1, yes? But I'm going to also need the negative to get rid of the other, aren't I? So what I'm going to do is I'm just going to leave it a negative right now, and I'm just going to say 1/4 R1. Now this isn't necessary. I could have done with what I had, the 3 and the 4, but I want to show you, can I make my numbers smaller? Yeah. So when I have big numbers, sometimes it's worth my time to make them smaller. Okay? So then I want that 3 gone. So now I just have to take 3R1 plus R2. Instead of having to multiply both rows, I only have to multiply one row now. That's a plus.
Where, So 1/4, you times row 1 by
Everything by,
1/4.
yep,
Okay.
okay.
And then you just drop the second row down.
Yeah, because I didn't change it. If I wanted to multiply it by the, like 1/8, I could have at the same time, but I can't. Okay, so then I'm gonna do this 3. So then I get, sorry, negative 3 is, oh, I told you I always do this and then I didn't go do it. Oh, that shouldn't be negative, should it? You guys didn't catch me. Should that be negative?
Which one?
The 2?
No. It should be positive.
It should be positive, shouldn't it? Okay, so negative 3, 3, 0. 6 minus 4,
2.
2. 24 minus 18, 6.
Wait, why is it not a negative?
Because 1/4 is positive.
Why is what not a negative?
Oh, 2.
Because the 8 wasn't negative.
Yeah.
Okay?
Oh.
So now I need this to be 1, but I also need this to be 0. So there's 2 things I could do. I personally am just going to go R2 minus R1. So that means row 1 multiplied by a negative, yes? So 0, 2, 6. So that would be 1. And then negative row 1. So negative 2 and 2 would be 0. Negative 8 and 6 would be negative 2. I'm almost there. I need this 2 to be a what? A 1. So 1/2 R2.
So, 3. So,
And negative 2, 3. So I have, let me stop my screen recording.